In this video, I'm going to tackle kind of a lengthy problem on indirect truth tables, testing for validity. Indirect truth tables will account for 40% of the problems, 40% of the points, that is, on test number one. So for this particular problem, I've gone ahead and written it out horizontally. Each individual premise is separated with a single slash, and then the conclusion L.G is separated out with a double slash. To complete this setup, I'm then going to assume, and it's just an assumption for now, but I'm going to assume that this argument is invalid. And I'm going to assume that it's invalid because there's only one way for an argument to be invalid. The only way for it to be invalid is if it has all true premises and a false conclusion. So as a result, I'm going to define each premise as being true. I'm going to define each premise as being true by putting a T under the main logical operator. So all true premises, and in this particular problem there are 4 premises and a false conclusion. And of course here there's just one conclusion. So the question then becomes this: given my assumption that it's invalid, what else can I know? And if nothing jumps out, a good place to start, then just take it one step at a time. So premise 1 is a horseshoe statement, a conditional statement, and I've assumed it to be true. But unfortunately, there are 3 ways for a horseshoe statement to be true. It could be T horseshoe T, F horseshoe T, or F horseshoe F, and we can't tell which is which. So I seem to be stuck here. Premise 2. Of course, I've also assumed this to be true, and yet it's a conditional statement, and so there are 3 ways to fulfill that condition. And I don't know which is which, so I'm stuck here too. Same in premise 3. Horseshoe statement, I've assumed to be true. There are 3 ways for that to be true. So I seem to be at an impasse. Premise number 4, I've assumed to be true. It's a wedge statement, but there are 3 ways to make a disjunctive statement true. T wedge T, F wedge T, T wedge F. I can't tell which is which. And now finally, the conclusion, a dot. I've assumed it to be false, but there are 3 ways to make this happen. It could be T.F, F.T, or F.F. I don't know which is which. So I seem to be legitimately stuck. And when you're legitimately stuck with these indirect problems, then it's time to construct what's called a mini truth table. We're not going to do a full-blown truth table as we did in 6.4, testing for validity, where you count up the number of unique variables and plug it into the formula L equals 2 to the power of n. That'd be one heck of a truth table. I have G, H, I, K, J, 5 different variables, G, I already counted G. I got 5 different variables, it looks like, 2 to the power of 5. That'd be a monster truth table. So rather than doing a full truth table, and yet I got stuck here, I'm going to do a mini truth table. And by that, I mean this. I'm going to pick one component of this argument, one premise, or I can pick the conclusion, and go through all the ways for it to be true if I pick a premise, or all the ways for it to be false if I pick the conclusion. So the question then becomes this. If you're going to pick one of these pieces and go through a mini truth table, then which piece should you pick? And there aren't any hard and fast rules, but let me give you a couple guidelines. Number 1, first and foremost, pick something that would be easy to work with. Why? Well, it just makes things easier. You don't want to create more work for yourself, and time might be a factor on the test. So which one looks easiest? Well, premise 3 and premise 1, these are way too complicated. So I'm immediately going to rule those out. And then think about, well, the leftovers here. Premise 2, the last premise, the conclusion. How do I pick amongst those? Well, they're all pretty basic. So pick one that has common variables. And there's the last guideline. Pick first and foremost something easy. And number 2, pick one that has common variables. We need our mini truth table to give us enough info to unravel the rest of the problem. So which one has the most common variables? Well, J, H, K, J, L, G. Let's just do a quick little glance here. The L just appears once. K appears once. The J's are in common for each of these 2 premises. The H only appears once. It doesn't look as though it makes much of a difference here. And so if it doesn't make much of a difference, pick one and run with it. I'm going to work with a conclusion for no particular reason, really. So what I want to do is go through all the ways for it to be false, of which there are 3. In no real order, it could be t.f, that'd be false. f.t would be false, as would f.f. These would all fulfill my original assumption. And so I've got a mini truth table consisting, in this case, of 3 lines, which means that I need to extend my original assumption for a total of 3 lines. And all 3, I want true premises and a false conclusion. So I'm now going to gradually chip away at this one line at a time. If you want to number them, line 1, line 2, line 3. In line 1, the way I've set it up, I've started with L being true and G being false. So every time there's an L, I'm going to put a T underneath it, and give me a lot. G though, that appears one time, right? So I'll put an F underneath the letter G. And notice I put it underneath the G itself and not the tilde. I've got my definition of L, I've got my definition of G. So from here, what else can I know? And take a look at the location of the L and the G respectively here and here. If G is false, according to our mini truth table, G is false, what's the value of not G? Well, if G is false, then not G has to be true. And so I figured the antecedent out, the value of the antecedent in premise 1. And let's continue here. I have T, the antecedent we know is true, T horseshoe, the main operator, and I don't know anything about the consequent. And if it helps, treat it as little 6.2 problems. I have T, the antecedent I know is true, horseshoe, there's the main operator, T horseshoe, and I don't know anything here, that's one big fat question mark. There's a little 6.2 problem where we started really with truth tables. T horseshoe something, and my assumption is that it's true. T horseshoe what is true? Well, the what has to be either true or false. What if it were false? Then I'd have T horseshoe F, but that'd go against my assumption. T horseshoe F would be false, and I've assumed it to be true. So that tells me that the question mark has to be a T. T horseshoe T is the only way to make that assumption work. So notice here, that tells me that the consequent is true. Notice that is that the dot has to be true. Here I didn't figure out the value of a variable, I figured out only the value of an operator. But nonetheless, that's valuable real estate. T horseshoe T is the only way to make that work, and so the dot and the consequent, the main operator of the consequent, has to be true. So let's narrow our focus there. We have something, dot, something, and we want it to be true. How many ways are there for a dot statement to be true? Well, there's only one way for a dot to be true. Both of the conjuncts, both the left-hand side and the right-hand side, have to be true. If there's an F in there anywhere, the dot turns out to be false. So I need T dot T to make that true. And notice again, I put the T's under the main operator for the first conjunct and the second conjunct. The main operator of the first conjunct, the only one there is the tilde. The main operator of the second conjunct is the only one there, the tilde. So I need T and T to be true. Now I can quickly finish up this premise. If not H is true, then H itself, working backwards, has to be false. If not I is true, then I itself, working backwards, has to be false. So notice I figured out H and I respectively. Every time there's an H, I'm going to put in an F. And every time there's an I, and it doesn't look like that took me anywhere else, but all I's would have to be false. So now on to premise 2. And I say on to premise 2 because I just figured out H, and I'm going to go with my new information. So 6-2 style, I have something, I don't know the value of J, question mark, horseshoe, there's the main operator, and I know H now for line 1 is false. Something, horseshoe, F, and I want it to be true. That's my assumption. Something, horseshoe, F is true. So what does that tell me about the unknown? Well, T horseshoe F would be false, and that goes against my assumption. So it's got to be F. F horseshoe F is the only way to make that true. So now I know J. J has to be false. So let's put in the J's. There's a J in that last premise, so it's got to be defined consistently J still has to be false. So again, 6-2 style, if that helps. I've got something, I don't know K yet, something wedge F, and I want it to be true. Something wedge F, and I want it to be true. Well, there's only one way to make a wedge false. F wedge F is the only way to make that false. Whereas here I want it to be true. So since one of the disjuncts I already know to be false, and I want the whole thing to be true, that means the K has to be true. If it were F wedge F, that goes against what I've assumed, so it's got to be T wedge F. And that makes K true. So slowly but surely we're chipping away at this thing. And the only part that we haven't figured out is now this third premise, right? So I've got the antecedent, K I know is true, horseshoe's the main operator, T horseshoe something, I know the L here, but that's not enough to give me the dot. I have T and something. Well, if M were false, the dot would be false. If M were true, the dot would be true. So I got a little real estate figured out here, but not enough. So let's return to the main operator. T horseshoe something. I know the L, but I don't know the value of the dot. T horseshoe something is true. So again, 6-2 style, if it helps, do it down here. T horseshoe something, and I want it to be true. So what does that tell me about the something? T horseshoe something is true. Well, it's either true or false. If it were false, I'd have T horseshoe F, but that goes against what I already know. So I need that question mark to be true. T horseshoe T is the only way to make that true. So I'll put a T under the main operator of the consequent, in this case, the dot. And let's focus in on the remaining piece of the puzzle. I now have T dot something, and I want it to be true. T dot something is true. Well, there's only one way to make a dot true, when both conjuncts are true. So that must mean that this remaining M is true. And notice my first line is now completed. I have T horseshoe T being true. Yep, that's the case. F horseshoe F being true. Yep, that fits. T horseshoe T really is true. T wedge F really is true. And T dot F in my conclusion is in fact false. So notice on line 1, everything fits. Everything fits. And so since everything fits, I kind of got lucky here. I don't need to go on to line 2. What this tells me is that my assumption is possible. My assumption is logically possible under just these conditions. It's possible to have all true premises and a false conclusion. And if that's possible, then the argument I know is invalid. Now that wasn't the case here, but what if I arrived at a contradiction in line 1, where L is true and G is false? What if it didn't end up fitting? Well, then I'd have to go on to line 2 and repeat the process. In line 2, L is false and G is true. What if I arrived at the contradiction there? Well, then I have to go on to line 3. So potentially these mini truth tables in 6.5, where you're doing indirect, they can be pretty long. Here it was long enough, but I, in some sense, kind of got lucky. I could cut it short after line 1, just the way I set it up.